Okay, so hello everyone. Today is the 14th of January. We are doing a code walkthrough pair programming on conversion. We're doing it based on the ClusterAPI provider, Bootstrap provider, CubeADM. I first start with some context around how conversions work, and then we just implement adding a new field essentially. Yeah, so let's get started. And I should share my screen. So here it is. Okay, so I also link that document in the chat. I think it will be also in the recording, as far as I know. Okay, so let's see. So first of all, why do we need conversions? So there are at least the following two use cases, probably more. First, as our APIs evolve, we are releasing new versions. And when we release a new version, we usually just add a new API version to our CRDs. So for example, we have V1 Alpha 3, then we change our code, our APIs, then we get V1 Alpha 4. And then our CRDs contain V1 Alpha 3 and V1 Alpha 4. And nowadays we have V1 Alpha 3, 4, and V1 Beta 1 in our series. And whenever we upgrade API version, there are still existing resources which have the old API version, and they have to be converted to the new one. And another use case is, of course, when we upgrade to a new version, we also upgrade our controllers. So when we release, I don't know, ClusterAPI V1, we have V1 Beta, in this case, we had V1 Beta 1 resources, and our controllers were compiled against V1 Beta 1. But of course, there might also be external controllers which are still using V1 Alpha 4. And of course, this shouldn't lead to any errors, because otherwise everyone would have to upgrade at the same time, which is probably not realistic. So let's make some examples. So I'm explaining this based on the CubeADM config CRD, and we assume we have, and that's the current state actually, we assume we have three versions, V1 Alpha 3, Alpha 4, and V1 Beta 1. There's something called a storage version, and the storage version is essentially the version which is used by Kubernetes to store it in etcd. So when you would look at etcd, we would find V1 Beta 1 resources stored there. So let's go through some use cases. First use case, it's not super realistic that a user tries to get an old version, but the use case is user tries to create a resource with old version. So actually creating a resource with an old version is probably realistic, but getting it isn't, because kubectl automatically discovers which version of an API is there. So if I type in kubectl get kubeadm config, it will just automatically check which versions are there, and then I'm not sure, but it will definitely pick V1 Beta 1. I assume it's because it's the storage version. Maybe there's also flags in series like default version or something. I would have to look that up. But what could happen is the user or CI pipeline still has resources with the old version. So it's realistic that someone tries to create an old resource. CubeADM configs are usually not created manually, but I use that as example anyway. So those resources are usually created by a controller, but that doesn't really matter. So what happens if a user creates VOF for kubeconfig? So kubectl will send the old CubeADM config to the API server. The API server knows that it should store it in V1 Beta 1. So it goes to our controller, because we, in our CRD, we configured a conversion webhook, which is our controller. So the API server asks our controller to upgrade from V1 Alpha 4 to V1 Beta 1. It gets back the V1 Beta 1 resource, and then it stores it in etcd. So that's pretty simple. And if I do a get, depending on the version, I mean, if I try to get a V1 Beta 1 version, it would directly return V1 Beta 1. If I try to get an old version, it would ask our controller again to convert. So now the next use case, which is what I already mentioned. So we have a controller, and especially third-party controllers might be still using old versions. And we could have a problem there. So let's assume our V1 Beta 1 resource has some new field, which is not part of the old resource. What could happen is that a controller which only knows the old structs retrieves a kubeadm config, modifies it, and updates it again. And because on client side, the struct doesn't have a new field, it could happen that that field is deleted. I think it couldn't happen if patch is used via the controller runtime client or client Go. But if you call an update, then the field would be definitely cleared because, yeah, the client just doesn't know anything about the field. And conversion is here to help so that the controller doesn't even have to be aware of that there is a new version. And here's how it works. We assume the controller gets the kube config, modifies the kube config, and then writes it again. So first step, the controller gets the old version of the kubeadm config. Then it will, the API server will first read v1 beta 1 from the etcd. Then it knows, hey, I need v1 alpha 4. So it asks our controller again to convert it. And then we return v1 alpha 4. Then the controller does some stuff to kubeadm config. And the controller writes v1 alpha 4 to the server. The API server asks our controller again to convert to v1 beta 1, and the API server stores v1 beta 1. So, and how is our field preserved now? Essentially through step 3 and 6. In step 3, the entire v1 beta 1 kubeadm config is stored as an annotation. So actually, the v1 alpha 4 kubeadm config user, the controller gets, has the whole v1 beta 1 kubeadm config in an annotation as backup, essentially. And as long as the controller doesn't intentionally delete that annotation, it is also written back here. And in this conversion, we take the annotation and we restore specific fields when we know that they are new in v1 beta 1. And yeah, that way it's not getting deleted. To make that a little bit more visual, I'll show how that looks in the API with kubectl. So let's see. So first of all, kubeadm configs, what do we have? Doesn't really matter. Oh, that's not what I wanted to see. Looks like I'm in the wrong namespace. Okay, so let's take a look at my cluster. So what we see here is that kubectl per default gives us the v1 beta 1 kubeadm config. We're not getting any kind of annotations here. So here. And it's just our regular structs. What we can also do is retrieve an old version of the kubeadm config. Just have to go back slightly. And let's just print it as YAML for now. Let's see which one it is. Okay. So now we're getting alpha 3. We're getting conversion data. And as you can see, we're getting the whole beta 1 resource here as annotation. And yeah, that's essentially it. If we take that annotation and extract it with JQ, somewhere back here, hope it's still the working one. Yeah, that should be correct. Then we see the whole resource. So yeah, that's how it looks like. Okay, so I think we established we need conversion. We know why it's useful. And now about one problem we could have. So let's assume we're releasing one new API version after another. So we're getting 3, 4, 5 API versions. What you would expect is that we have to be able to convert between all of them. So I don't know, someone writes v1 alpha 4 and reads v1 alpha 3, then you might assume that we have to be able to convert from alpha 4 to alpha 3 and do that between all versions. So there's a really great picture in the kubeadm book which shows that problem. So those are our API versions, and naively you would think you have to convert between all of them. But Kubernetes, or I think series essentially, has the hub spoke model. And the idea is you have one version in the middle, which is called a hub, and you have the spokes. And you always convert to the hub and from the hub to the next version. So in our example, we're converting alpha 3 to beta 1 to alpha 4. And the hub version It doesn't have to be the storage version, but in case of ClusterAPI, it's also the storage version. And this way, we only have to implement conversions from and to the hub and back from the hub. So essentially, we have to convert from alpha 3 to beta 1 and back, and from beta 1 to alpha 4 and back, and not any kind of alpha 3 to alpha 4, for example. So that's just some additional detail. Yeah, so some word about Bootstrap provider kubeadm. It's a little bit more complicated than our regular provider and the regular APIs. So the current state for all our providers is that we have, or all our providers in the core repository at least, that we have alpha 3 resources, alpha 4 and beta. Beta is our hub and our storage version. And whatever user read or writes, we can just convert to beta 1 and back, and that's it. And the resources are stored as beta 1, as I said. In case of kubeadm, there's one additional difficulty, and that is that we also have upstream kubeadm APIs. Some background. So essentially, we have our own, differently. So our kubeadm Bootstrap provider APIs contain something called, I think it's kubeadm config spec. I'm not sure if it's that layer or a little bit deeper, but essentially we're embedding kubeadm structs. And because we didn't want to embed them directly, we have our own copies of those structs. So essentially a user just interacts with our copy of the kubeadm structs, which is just in one version. And when the controller then tries to create cloud init, or nowadays also ignition, for kubeadm, it takes a look at the Kubernetes version, and then it generates the kubeadm configuration file as YAML in the correct version. So not 100% sure, but something like, just an example, if we have an old Kubernetes version, we are using beta 1. If you have something like 1.19, just an example, using beta 2. And if you have 1.21, we're using beta 3. We'll get to that point later where you can see in the code. So we have to do two things. One, just for controllers and for users, we have to convert between the public types. And then actually at runtime, when we use that information to generate cloud init stuff, we are converting to upstream types. And that makes it a little bit more complicated. Okay, so now let's see how to actually implement that. We're doing that based on a recently open PR. The goal of the PR is to, let's open that file here, to add a new patches field to the init configuration and to the join configuration. By the way, if there are any questions, just interrupt me anytime. I also have to chat open. So first of all, we have to add the field to respective types. So what we already have is, some word about code structure. So as I mentioned here, we have our public APIs. Those are those three packages. And we have our upstream kubeadm APIs, which are those three packages. And the new patches field we have here is something which was introduced in the kubeadm upstream API in v1 beta 3. So our goal is essentially to add a field to this package and to this package to make it accessible to our users or via our user-facing API. So first of all, we have to add the API type here in the upstream v1 beta 3 package. So we have init configuration, patches. We also have a new struct, which is the patches struct. And for completeness, just to show, we have the same thing in the join configuration, I think. Yeah, that's the join configuration. So join configuration and the one above is the init configuration. So that's already all we need in this package. We have to do the same thing here. So usually our types are stored in files which have just the same name as struct. So we have kubeadm config types, which is a kubeadm config, but we made an exception for kubeadm types. So we have just a separate file which just contains our version of the upstream types, or shim, we call it. So that's just, our version. So let's see. there might be more differences, but I'm just using that to easily add patches. So we're currently not supporting all upstream fields. Some don't make sense. Some just haven't been added yet. So certificate key is just something which doesn't make sense in the context of ClusterAPI, for example. Skip phases is not implemented yet. So that was patches in the init configuration. And I guess somewhere here, the join configuration should be the same, but I'll copy again. And at the bottom, we should have the struct. That's some additional code from us. So let's add it here. I think overall, it absolutely makes sense to try to keep it as sync as possible because it's just easier to diff. And we have to do this from time to time. Okay, so now we have the field also in QBDM types. Next step. So we have a bunch of code which is based on those types. So for example, we have deep copy. So deep copy essentially that you can copy all the structs without having, I don't know, if you want to have a separate copy that you're not overwriting the original object. That's where they're usually used. So in the terminal, let's run make generate. Oh, it's the wrong order, but let's just do deep copy for now. So here I actually start with CRDs. So that target is relatively fast. So that's so I'm running it just on the whole already on the whole repository. We also have targets which only run it for the bootstrap provider, the control plane provider, or some of the others. But in that case, we can just run it for everything. So that should give us some changes in deep copy. So essentially, when we deep copy init configuration, we are now also copying the patches. That's, I think, pretty straightforward. Next thing, based on types, we are also generating our CODs, of course, because otherwise Kubernetes would know about our fields. So we should get some changes here sooner or later. And after IntelliJ refreshes that file. Yeah, there it is. So let's see, just something with patches. Yeah, so our Go doc and the field, etc. Everything here. Okay, so we've upgraded deep copy and manifests. Now the most annoying part, we have conversion functions. So some context, it's not like we're writing the conversion between those types entirely manually. We have some auto-generated functions, but the auto-generated functions, they can only convert if they know what to do, essentially. So it's easy for conversion to just convert fields of structure which are entirely the same, or just copy over fields which didn't change, but it doesn't know what to do if, I don't know, the type of we're not usually doing this, but if the type of a field changed, or if a field is new or a field was removed, then a conversion that just doesn't really know what to do, and that's where we have to add our code. But first of all, let's do make generate Go conversions. So here, important to mention, generate Go conversions is very slow. So even only for the bootstrap provider, I think it takes like 5 minutes on my machine. So we have in theory a target for the whole repository, but I would suggest to only run the provider specific ones. To not have to wait here 5 or 10 minutes, I'll just diff that against my branch where I already did it. It would be just running those targets and waiting 5 or 10 minutes, but let's not do that now. So what I will do is I just do the changes myself. Okay, so what changes here? Essentially, the new version, it adds a warning here that in.patches requires manual conversion because it does not exist in the other type. It also removes that function. So before it knew how to automatically convert from init configuration beta 1 to alpha 4. Now it doesn't know. Because we have a new field. So our job is essentially to implement that function as we think it's correct. And we should have a similar diff here. Yeah, so same in the join configuration. And yeah, I think, let's see what that is. entirely sure. Yeah, so I think before, when it converted an entire kubeadm config spec, it could just do some pointer magic because the structs were entirely the same. And now it has to call our functions actually to convert them individually. And the same for, I guess, I'm not sure what that other part was. I guess we use them at 2 places. And, oh no, that's fine. So that was the conversion in the public types. And in the upstream types, it should be kind of similar. Yeah, so just go over that pretty fast. Oh, that's my code. That's something you do later. Okay, so now our conversion should be done, or our generation of the conversion code. So now let's try to implement the conversion from our side. As I said, the conversion doesn't know what to do in some cases, and we have to fix that now. Those are usually also compile errors. So at that point, you could also run just make lint, and it would show you, or something else, just compile the stuff, and it would show you a bunch of compile errors. And at that places, you have to take a look what's going on and fix it. Oh, actually, we start with the upstream types. Doesn't really matter, but I think I thought it's a good idea to fix those first. So beta 1 generate conversion. So what we see here is that it's now calling 2 functions which don't exist. And that's our job to implement them. So we're usually doing that in the conversion go. So please do that the same way. Yeah, so we have to implement that function. Let's see what our name is. Okay. So we have to convert from beta 1 init configuration to upstream beta 1. So that's our public type. That's our internal type. In the public type, we have the new patches field. In the upstream beta 1 type, so in the old kubeadm version, essentially, we don't have that. So I'll do a bunch of copy paste because it's just faster than writing it manually. So our input is our upstream v1 beta 1 init configuration. And our output is just init configuration, and that's the one of the current package. So that's upstream v1 beta 1. The scope is always the same. And what we're doing is we're just calling the autoconvert function. So I'll explain that in a minute. So the conversion didn't generate that function, but it generated this function. And why does that make sense? So essentially, this function is there, I think, only so that we can implement it, but it will always generate the autoconvert function. And the autoconvert function just, let's say, does it best to convert what it can convert. So it will convert everything which is there in both structs, but it won't convert the patches. So, and I think the idea is that in those cases where we have to implement it manually, we don't have to implement that stuff, and there's even a lot more of that code in there. So every field, we would have to copy every field manually. So we don't have to do that. Our implementation is essentially just that implementation. And we could do some additional stuff, but in our case, we're just saying, hey, init configuration.patches does not exist. So we're just not doing anything. So we could do something to the upstream type. So if there is some way to take the v1 beta 3 new field patches and implement it in some other way in the older version of the API, we could do that here after that auto conversion, but as there isn't, because the field just simply isn't there and there are no other fields which could provide the same functionality, we're just taking that conversion and we're essentially just dropping the patches field. And that's just something which the conversion didn't want to decide for us. So we have to say, okay, that's fine. We just ignore that. And it's the same for join configuration. That's not different in any way. Yeah, and that should fix the conversion, the compile errors here. I hope. Yeah, so now it's green. I think it should be roughly the same here. So let's do even more copy paste. Yeah, so we're missing the view on beta 1 to upstream view on beta 2 because it's upstream view on beta 2 functions in that case. Okay, and we have to replace that. Oh, yeah, that was bad. So replace all. Okay, so just the same for upstream on beta 2 because the field also doesn't exist there and we can't do anything to implement that functionality. Okay, now that's good too. And yeah, what about upstream view on beta 3? So here everything is fine because the field exists in view on beta 1 and in upstream view on beta 3. So nothing for us to do. I think there should be something like, yeah, so here's, okay, that's not the one I want to click on. It's interesting though. Ah, okay, so those are also auto-generated functions. I was thinking for a moment that we are in conversion.go. Yeah, so in this case, it generated a bunch of functions to convert patches. But yeah, as the structures are entirely the same in the public type and in the upstream type, it's just able to do that automatically. I think there should be also some kind of join configuration to join configuration functions here. So that's the one we have to write manually in the other case. In that case, we just have to auto-convert, and the auto-convert does that pointer magic here. So it just, yeah, takes the data of the old struct and or of the input struct and puts it in the output struct. So that should be fine too. I'm not sure what the problem here is. That's pretty strange. Okay, let me diff for a moment with how it is supposed to look. Okay, should be fine. Maybe let's ignore that for a moment and finish the public types. And not super sure what the problem here could be. Okay, so that was upstream types, public types. So let's now forget those upstream types entirely. Now we have to convert between alpha 4 and beta 1 and back, and alpha 3 and beta 1 and back. That's usually the only thing you have to do for other providers because they only have those packages. So similar compile errors here, usually, hopefully, I think. Oh, it could be, yeah. So I think we don't have an issue in alpha 3. I confirm for a moment. Yeah. So in alpha 3, we don't have an issue because there were already changes for, I think, init configuration or join configuration before. So it didn't really change a lot. So there should already be functions like convert view on beta 1 join configuration. So we don't have to add them, they're already there because in that case, ignore preflight errors was changed before. So it's just, yeah, already there. But in view on alpha 4, we have the same issue. So let's start with that one. Again, I just copy one of the existing ones because it's just faster. And I deleted comment because it's actually wrong. So that is not an auto-generated conversion function. That's manually written. But okay. Let's see. We convert from beta 1. The message was wrong. Yeah. Okay, now it's fine. We convert from view on beta 1 in configuration to view on alpha 4 in configuration. So that's view on beta 1 init configuration. And that's just the current package because we are again in the view on alpha 4 package. And the autoconvert should be the same or similar here. So that should be init configuration. Yep. So, and again, that's that. And the same for join again. Any questions so far, or sounds plausible? Okay, then I assume. Yeah.
Stefan, just one doubt. Is there a semantic difference between a convert function and auto convert function? I mean, the generator, when does it, when does it create a convert function and when does it create an auto convert function?
Okay, so if the structs are entirely the same, it creates both functions. It creates the auto convert and the convert. If it detects a difference, which it can resolve automatically, like you have one more field in one of the types, it will only create an auto convert function, and then it's on us to convert a convert to sorry to implement this convert function.
Oh,
so
thanks.
I think it only generates both in the case of everything is the same to keep it consistent, I guess. So in the case where we don't have to intervene manually, I think that function is not strictly needed, or that one, it could just generate one of them, but maybe it's for simplicity and consistency that it generates both.
Thanks, Stefan.
No problem. Okay, so that should be everything here. So no compile errors here, no compile errors here, and of course none here in beta 1. We don't have a conversion code in beta 1 because we just have to convert from alpha 3 to beta and to alpha 4 to beta 1, and all the code is here. So the code to generate from alpha 4 to beta 1 and back is entirely in that package. What we have here is some marker functions. So I talked before about hub. This function is there to signal to controller runtime that the view in beta 1 version of that type is the hub. There should be similar. I'm not sure if it's not needed for spokes. So if the hub functions are there, it's the hub, and if not, you have a spoke. That's relevant later on. Okay, yeah. In theory, we could run make lint, but let's skip that for now to check for further compile errors. But I assume it's fine. Okay, so now let's see if the conversion works. One step back. So we've implemented a conversion. It's not complete yet, but how do we validate that the conversion actually works? We have tests for that. They are called, I guess, Fuzz tests, conversion Fuzz tests or something. They're looking like that. Test fuzzy conversion is the name. And what they're doing is the following. So in that case, let's take a look at the public APIs. It makes more sense. It just makes more sense. So in alpha 4, we have fuzzy conversion functions for kubeadm config and kubeadm config template. We tell that function what a hub and a spoke is, and everything else is implemented by that usual function. And what that test is doing is essentially it generates, let's take the kubeadm config one. It generates a hub with random values, then it converts it to spoke and back, and then it compares the initial version of kubeadm config before the back and forth conversion and the result, and it makes sure that there is no loss there, so that we're not losing any fields. And that is run, I think, a bunch of times for every for every direction. And we're doing this for hub, spoke, hub, so for v1 beta 1 to alpha 4 and back. And we're doing it also for we're generating alpha 4, then converting to beta 1 and back, so in both directions, that we're just absolutely sure that we're not losing anything. And what we are doing now is we're running those conversion tests to figure out if our conversion is already done, which it isn't, but that's just a systematic way to find it. So I just run that thing here. I think that one should be fine because there shouldn't be any manual work. Yeah, and that's the point where I don't understand why we had to point the error and we still have it. Okay, that's interesting. Let's see if you can figure it out. I'll just diff it for now. Oh, that's interesting. I'm not sure why, but it seems like we're missing some deep copy functions. Let's rerun the generation. That's pretty strange. Let's see if that works. So I've actually never ran a deep copy target before, and then the code wasn't there. So not sure how that happened. But yeah, so that should fix that now. I assume we probably have a problem here because the interface doesn't match or something. Cannot use, yeah, maybe because the type is different. Maybe it's something else. Check if there were some changes. IntelliJ is sometimes slow to refresh the files. Yeah, no, so there weren't any changes to deep copy. Okay, I'm slightly wondering why it was there on my other branch. So I've implemented that before just to make sure I have a clear road to the solution. Let's see if there was some. Oh yeah, I know what the problem is. Okay, so I've started with the currently open PR, but when I did it yesterday, I did a small, very small modification, which I totally forgot. So I checked again how the upstream types are implemented. And on the currently open PR, there was one very small error. And that is that we have to use a pointer here. So because patches is optional, it's a pointer. And because now I have, I probably have the same error in both, I guess, also on the public types, because I copied it from here. Yeah, but we should really implement it in exactly the same way. So that if in the upstream types, those are pointers, they also have to be pointers here. So let's see if that works then. I think so. I think it would also have worked if I would have really run the conversion targets. But as I used those which were based on the pointer from yesterday, yeah, there's that mismatch. Let's see, we should have the same difference here. I think, no, not that. Yeah, so pointer here too. And then I think that compile error should be gone. And I regenerate the deep copy functions because I think now it will change something because of the pointer. Okay, something flipped slightly here. Yep. Okay, so I guess you have to deep copy pointers differently than everything else. Good. So no compile errors here. No compile errors here. And now let's run the conversion code. The conversion tests, I mean. So doesn't really matter which one we start with the upstream or the public ones. Let's start with the public conversion function because conversion tests, because that's what you have to do for all providers and not only and the other one is only for Cube and Bootstrap. So conversion test. Let's see what errors we get. That's the wrong window. So looking back here, we're now testing Kubernetes config and conversions between. We are in the v1.4 package, so we're testing those conversions here. I'll make that a bit smaller. And it takes a bit of time because it. I'm not sure how often it runs the test, but a few times. And that's actually code for it. Yeah. Yeah, we're running it 10,000 times in both directions to absolutely make sure. And there are some cases where the automatically generated values are not valid values, and then the serialization fails. But yeah, that's just to detect edge case. So when you yeah. So let's see. So we have an error when we convert from v1 beta 1 hub to v1 alpha 4 and back, then we get a difference. And the difference is in that diff here. It's a little bit, yeah, you have to know some stuff to read it, but so essentially, if you see differences between a field is nil or the map, that doesn't matter. That's just part of the diff output. It's not actually a problem. So that's not something we have to fix. I'm not sure why the difference is, but yeah. Our interesting thing is more related to patches. So we see when we convert from beta 1 to alpha 4 and back, then we're losing patches. So in our generated beta 1 kubeadm config, we had patches, and after conversion to alpha 4 and back, we lost patches. And that's not something we want. So let's see what we have to do. And why are we losing them? We are losing them because currently in our conversion, and that's the auto generate. That's where we, let's say, integrated us in the auto generate code. Here we just said, hey, we're not doing anything. Patches is gone. That's fine for us, and that's why it's gone now. Okay, so now I have to explain how it all fits together. Please ask if it's unclear. So the only thing we have here is the auto-generate functions, and those functions we have to implement instead of the auto-generation because the generation didn't know what to do. As I mentioned before, what's actually, how those functions are actually used is that the API server asks our controller, please convert from alpha 4 to beta 1 or something. And it's not calling those functions directly. So controller runtime calls the convert to and convert from function. I'm not sure if I should show that part, but yeah, maybe let's do it. Otherwise, please just ignore. So where do we get from the API server calls our controller to controller runtime calls those functions? Essentially, we have the webhook registration. So when we bootstrap the controller, we are registering this type as webhook. And what that does is essentially here it registers webhooks. So it does something for defaulting and validation, but for us it's interesting that we have conversion. So in register conversion webhook, if the resource is convertible, and convertible is something like if it implements the right interfaces. So that's where it checks if the hub interface is there, the hub function is there to fulfill the convertible interface, and it checks if the convert to and convert from functions are there. But if that's the case, it registers the conversion webhook under /convert. And the conversion webhook essentially is what implements that endpoint. I wouldn't go too much into detail, but essentially it's an HTTP endpoint. It decodes the incoming kubeadm config, and then it does convert object. And convert object is more or less, okay, let's take that incoming object. Let's figure out in which direction we have to convert. So if you have to, for example, we convert from alpha 4 to beta 1, then it tries to figure out which one is the hub type. And then it does some kind of conversion to get from one to the other, from alpha 4 to beta 1, for example, by calling the correct convert from or convert to function. And I think that's where I would leave that. But you can always step through that code. It's pretty easy. It's just request comes in, the resource is parsed. Let's figure out which functions to call, what is hub, what is spoke, and call convert to or convert from. And yeah, and that's where we are leveraging the auto-generate function. So for all types we have, it doesn't really matter if there are differences or not, but for all types we have to implement the convert to and convert from. In the easy case, it's just calling the auto-generate function because everything is there. So in this, for this type, there's just no difference. So we can just use that function. But for kubeadm config, it's different. So already before our change, we had to backup restore some functions. Let's see how that works. So as I said before, step 3, the kubeadm config is converted from beta 1 to alpha 4, and we will store the entire beta 1 resource as annotation on the alpha 4 resource. How do we do that? Essentially, we are calling the regular conversion function, which just does some field copying, and that's it. And then additionally, we call marshal data. And marshal data takes source, which is our beta 1 resource. It marshals that as JSON and adds it as annotation on destination. So that's not super complicated. It's just JSON marshalling, add the annotation, and set it. So that's the way we create a backup I showed before, somewhere here. So that's how that annotation here is produced or written. And now back, that's convert from alpha 4 to beta 1. That's essentially that part. So first we do the naive thing and just call this conversion function, but this conversion function doesn't know about our field differences. Then we take the annotation, unmarshal it in that struct, and then we can restore things from our restored object to our destination object. And unmarshal is also pretty easy. It's just take the annotation, unmarshal it, and yeah. And here we make sure that in the restored object we don't have the annotation, but it's not super important. Yeah. Okay. So questions? I know that's. I'm not sure if I explained it well, but. Okay. Then
I guess I have one just quickly. Sorry.
Yeah, absolutely.
Just in terms of confidence, when you've implemented these functions and you run the fuzz test, should you be pretty much 100% confident that the conversion, your implementation is correct?
Yes.
Yeah.
Yeah. Yeah. I think there's. I wonder if there's something you could do wrong. Let's say as long as you don't hack the fuzzer by implementing some custom fuzzer functions. Right. It's 100% safe because it's generating all fields, converting it in all directions, and make sure that nothing gets lost. You only have to start to think, and we get to that later when you modify the input of the fuzzer and say, hey, this field has always that value, and then it gets dangerous.
But from a normal adding field conversion or whatever it is,
usually it's not
you don't need to do a manual inspection or anything. It's once
working,
that's fine.
Essentially you can follow that workflow, add the fields, write the conversion functions here, do some stuff here, or maybe run the conversion test before, and if everything is green, everything is fine. And if you get errors, you have to figure out how to fix them, and there's different ways to fix them. Yeah, but let's see. Our current cases, they're reducing patches. What we're already doing for kubeaim config is creating the backup as annotation. What we're not doing is restoring the patches field. So let's see how we can restore the patches field. So we take a look at our restored struct. And I'm not super sure where that is. Spec, init configuration, and then patches. We have to be careful because init configuration is actually a pointer. So because we're fuzzing all the things, it could be that init configuration is not even set. So in this case, we have to be careful and only restore it if that's not nil. Otherwise, you will see a nil pointer dereference in the fuzzer test. Okay, so now that we know that init configuration is actually set, we can take patches and we can set it here. One interesting thing, you might think that you have to take a look at if patches is nil or not, but that doesn't matter because if it's nil, it's just set to nil, so it's a no op essentially, and if it has some content, then it's some content. So on that level, we don't have to care about that. But the fuzzer test finds those kinds of bugs pretty immediately. Yeah, always. I didn't have a case where it didn't found it, so I guess the 10,000 times I make sure that you're hitting all the cases. Yeah, and the same for join configuration. Now I would think that that test works for kubeaim config because we fixed kubeaim config. We didn't fix kubeaim config template yet, but that's something we have to do too. But let's wait for a moment to see if that's enough. And back to my, just making sure I didn't miss anything. So here's just some explanation to read up after.
So we'll have to repeat the same thing for V1 Alpha 3 as well, right? So
Yep.
we'll have to repeat this for all the spokes with respect to the hub. Right?
Yep, exactly.
Okay. Oops.
Yeah, here I just wrote, you have to make sure that you do marshal data in convert from, and that you do unmarshal data plus restore fields in convert to. And usually there's enough. I'll show some other case later where you have to do more than that. Okay, so that's the kubeadm config. Same issue in kubeadm config template. So you will see that here we have patches. And just go down to the kubeadm config template. You already have convert who from, thanks to the Ignition PR. So they had to add that too. It's pretty similar here. The only difference is that it's in spec template spec, I think. So let's see if that compiles. Oh, typo. Okay, so that should be good too. Let's run a test, and let's just do the same here while the test is running. To speed up a bit. So you see, it's even if it's entirely prepared, it's it's still a bunch of work, which takes some time to do. Okay, so we have a bunch of more restorations here. So we see in the alpha 3 case, there's already more going on, but yeah, we don't have to care about that. So that's actually the wrong one. Let's just fix that. And then we're in kubeadm config template. And so copy paste is definitely your friend in that case. Yeah. Okay, so that should be fine too. And let's also start the conversion test in alpha 3. And if I didn't forget anything, then it should be fine. So I mentioned before, there are some cases where fixing it like that is not enough. So currently, we assume that all values that a fuzzer generates are valid. I mean, it takes, I don't know, it takes your struct, looks at a field, it's a string, it generates a bunch of strange strings. Everything works out. Usually that is fine. But in some cases, we have our, let's say, custom types. So for example, we have a bootstrap token, which has custom JSON serialization, where not every value is valid. And in those cases, you can customize the fuzzer. It essentially works like this. If you look at the test fuzzy conversion, you'll see that we pass in some fuzz functs here. Yeah, let's ignore that here. Essentially, the fuzz functs look like that. The name doesn't matter at all. The parameters are whatever fuzzing, or for which type the fuzzing you want to customize. So in this case, we want to have our own fuzz logic for the bootstrap token string. So we just take the bootstrap token string, and that's always there because you can use that to say, fuzzer, please fuzz that field for me if you try if you customize a whole struct or something. And in that case, we're just setting that fake ID and fake string, fake secret. Those are just fixed strings. So actually, the bootstrap token string is not actually fast. It's just always fake ID and fake secret. Because if it would be fast, we would get some strange characters. I think in that case, I'm not sure what the serialization for bootstrap token string does, but whatever, not everything is valid. And if you use the fuzzer, you will get some strange errors here. So the unit test would show you something like couldn't parse JSON because of some strange character. And yeah, but feel absolutely free to ask if you hit some issue like that. I think that's the most, yeah, the strangest edge case we have regarding conversion. Okay, so let's see. The alpha 3 conversion was green, the alpha 4 conversion was green. So we're done with the public types. So for all other providers, we would be done now. I mean, of course, we would push the PR, run all tests, and make sure that everything really works. But apart from that, that's all you would have to do. But for the bootstrap provider, there is more. Yeah, just ask. if there are some questions.
Stefan, one question. So these first tests, right? They are the input that these first tests take for like the QVDM config spec input that it takes the different fields. Where do we find those artifacts for the test?
Yep. I think I just show you how the test runs. So let's run one, and I show you how it works. So we will be running that test here, and I'll add a breakpoint here. So QVDM config. Goal of the test is to convert beta 1, alpha 4, and back, and let's run it and see what it does. What we tell the test is which types we have. So that's the beta 1, and that's the alpha 4 type, and those are the customization functions if we want to do something special for some fields. Then when we run the test, we are creating a fuzzer here, and now we're running the following 10,000 times. So first we have spoke before. So that's actually in that case here. That's I think I ran for alpha 4. So that's our alpha v1 alpha 4 QVDM config. So the spoke before here is just that should be a deep copy of an empty object. So there shouldn't be anything here, everything nil. Then we run the fuzzer. The fuzzer will set a bunch of stuff randomly. So I guess here we have some fields. Then it will first run the convert2. The convert2 converts our v1 alpha 4 object to the v1 beta 1 object. So now we're doing this direction. And we expect that there are no errors. Then we take our beta 1 object and we convert it back to alpha 4. So now we have spoke after. Let's skip that for now. That's some detail we shouldn't care about now. That's 2. And what we're now doing is we are checking if our initial v1 alpha 4 struct is identical, semantically identical to the one after. And I think the semantic deep equal, that's the difference where you where it doesn't care about if an annotation is an empty map or if it's nil. That's why we're using semantic. Yeah, and if that's fine, we just continue. And then we do this 10,000 times, and that's it. Does it answer the question? So essentially, we don't have any kind of test data or something. We just have the structs. We generate some random values and make sure that after we run them through the conversion and back, we're not losing any of the generated data.
Okay, thanks. That answers my question. And just curious, why do we have the 10,000 iteration? Is that
just to make sure that we cover all cases? So, for example, if we generate it once, we have a node registration here, for example. But what about if we forgot this nil check here? We wouldn't find it with that. It would be totally random if you would find that issue. But when we run it 10,000 times, we can be pretty sure that there is one case where that is also nil, and we would find the need for that if. So that's just doing it some more and making sure that we're finding edge cases.
Understood. Thanks.
Okay. Good. So that was the public type conversion. Now let's see what we have for kubeADM Bootstrap specifically. So let's start with Upstream v1 beta 1. And we can see here what we are trying to achieve. So now we're not talking about Kubernetes resources. So because we have the full resource here. So here we have a kubeADM config template. Those are just our API types. Here we're talking about cluster configuration, cluster status, init configuration, join configuration. So why is it that like that? So the kubeADM Bootstrap provider, at some point, as I mentioned before, sometime, it takes our public v1 beta 1 resource, and then it generates a YAML, which is then the input for kubeADM. And we don't have to convert the whole resource. We have some structs embedded which you want to use, and those structs are cluster configuration, init configuration, join configuration, And yeah, in beta 1 also cluster status, I'm not sure if it's still there in beta 3, but we only have to convert those structs and not everything. So that's why we are only checking those conversions and not the whole thing, because that's what kubeADM needs from us. Yeah, and what that test verifies is if we can convert from the public cluster configuration type to the upstream type. I intentionally only draw the arrow here in one direction because we don't really need it back. So kubeADM only takes our types and converts this for kubeADM. We don't have to convert back. So only this direction is important for us. The tests are written in the same way because we can use the same function. So it will also test the whole round trip thing, but we only care about that direction. We don't care about if we can convert from the upstream types to our public types. Yeah, so let's see if the test works. Spoiler alert, it doesn't.
Stefan, quick note. In reality, we care about conversion back because kubeadmin stores the data in a config map, and during update, we read it, and we have to convert it back, basically.
Oh, good point. Yeah, I wasn't aware of that. Okay, so let's see. Yeah, so init configuration, join configuration, as expected, I guess. We're losing patches again. And I wonder if that's a problem for Bisu. But let's see. I'll first fix it how I would have fixed it, and then let's see if that's good enough. So because we're not talking about full Kubernetes resources, we can't really put anything in an annotation because join configuration doesn't have metadata annotations. It just isn't there. So as far as I know, what we usually did is we just set it to nil and we just ignored that case. But I slightly wonder if that's a problem for our back conversion. You muted?
So first of all, a little bit of context. Here we are using, what we really need to do is to convert our types to kubeadmin types. So we are using API machinery just for convenience, but let me say, any other solution that you can imagine will be fit for the problem. Could be used as alternative, but here we are using API convention, API machinery, because we already have it in the project and we are kind of used to it. So, okay, then the problem that we have to solve is the following. The ClusterAPI API existing in only one version, let me say V1 Beta 1, the latest one. Then with ClusterAPI, you create clusters that are of different Kubernetes version. I create cluster V118, V119, V120, and so on and so forth. Okay, this means that your V1 Beta 1 version should become something that kubeadmin understanding in that target version. So when I convert to V118, I need probably to go back to kubeadmin V1 Beta 1. When I'm to Kubernetes version V123, I need to be V1 Beta 3. So I need basically to speak the same API version that kubeadmin in my cluster speaks. And what happened? That now we are talking about a new field, which some new field that exists in kubeadmin only in the latest version. And given that, if I got it right, the PR, we are accepting that if the user set this value in the spec, but then targets Kubernetes version that does not support this field, basically we lose them. So we silently ignore them. So it is fine that in the conversion we lose them, and then in conversion back we don't get them back. The only things that we have to do is that you have to teach your fuzzy test that this fact is not a problem.
Yep, absolutely makes sense. Okay, and that's what we're doing now. I just doing it here because it's easier. As I said, we can customize the fuzzer with those fuzz functions. So what we'll do is we will add one for init configuration and one for join configuration here in the list, and they are looking like that. And let's switch the window. And yeah, those fuzzer functions look like this. So we take the init configuration. We use the fuzzer to just first fuzz all the fields. And then we're saying, hey, patches is nil. And we're saying patches is nil because, yeah, patches does not exist in the upstream type. And here we make sure that the fuzzer only generates types which wouldn't lose anything. So we have to set patches to nil, so then we can also not lose patches. Does that make sense? I hope. Yeah, and that way we'll just never hit that case where patches would be anything but nil, and that's why it works now. And it will be the same for beta 2. So let's do that too. Yeah, I also just did it here again. Yeah, and if I didn't forget anything, I think we should be done. Yeah, I think I covered all the things. I'm not sure if there are open questions. Feel free to ask anything about conversion, especially stuff I didn't mention, if you're aware of it. Fabrizio, I think we probably should add that in the book in some way. But I'm also not sure what is in the book already. So
I think that okay. I don't know. This is let me say, here we are using API machinery or controller runtime stuff. So maybe that the right thing, if people think that this is not clear enough, I think that the solution is to go and PR Kube Builder documentation or stuff like that. So the entire ecosystem of project built on top of Kube Builder can benefit from the documentation improvement.
Yeah, I think I'm not sure how KubeBuilder sets it up, but I think that a lot of what I showed is ClusterAPI specific. I'm not sure if they also have fast tests. It looks like they were implemented only here. But yeah, we can discuss that later on.
Yeah, but let me say, in Kubernetes, in every API, you have fast test. In every Kube builder, let me say, they are not auto-generated, but if you are a savvy person, you implement them. Yeah. Because there are too many corner cases and fast tests basically stress them for you.
Yeah, absolutely. Okay, yeah. So if there are more questions, just ask. Otherwise, I think we're at the end.
Okay, thanks, Stefan. This was great.
Yeah, no problem.
Yeah, thanks, Stefan. This was really great.
You're welcome. Okay, then have fun. I'm not sure. I can push that branch for you for the specific PR. You can also implement yourself. Totally up to you. Yeah.
Yeah, both will work. I can try implementing it, and like this video will be out. Like if I face any problem, I can just review it back.
Yeah, perfect. Yeah, I'll send you the branch somewhere, and you can just try it. And if you want to look it up, then you can look at the video or the code. Perfect.
Yeah, sure. Yeah, thanks, Stephen. Thanks for this.
Yeah, you're welcome. Okay, see you.
Yeah,
Bye-bye. I'll post the video somewhere.
Yeah, sure.
Thanks, folks.
Thank you. Thanks.
Thanks, Stefan. Bye.